The next set of identities we need to learn about today are called the odd and even identities, and they have to do with the fact that some of the trig functions are odd and some of the trig functions are even. Just a reminder that odd means they are symmetric to the origin, and even means that they are symmetric to the x or the y-axis. So for example, the cosine graph looks something like that, and if we were to fold it down the y-axis, it would be symmetric on both sides. And the sine graph is more something like that, where if we turned it upside down, we would still have the same graph going the other direction. For these identities, though, to help you understand them a little better, if we choose an angle that's negative, let's say negative 30 degrees or something, that the sine value of negative 30 degrees would be like negative 1/2. So if we did the sine of negative 30, the answer would be negative 1/2. Well, what if we did the sine of positive 30 degrees? The sine of positive 30 degrees is a positive 1/2. So let's look at this identity called the odd identity. It says if we take the sine of an angle x, but we take the sine of the negative version of that angle, so let's say, for example, negative 30, then that's going to be equal to the opposite value of the sine of the angle that's not negative, the same angle. So let's say the sine of negative 30, which is negative 1/2, is the same as the sine of 30, positive 1/2, but negative, so negative 1/2. So this identity is true because negative 1/2 is equal to negative 1/2. And this will work for any angle that you plug into sine or tangent or cosecant or cotangent. The negative version of that same angle will be the same as the opposite ratio of the angle that's not negative. And that's because it's an odd function. If you go to a positive angle, you go to a positive y value at that part of the graph, the negative of that same angle would be a negative value, which is where that negative comes in. Then these functions are known as even functions because if I plug in a negative angle, I get the same answer as if it was positive. So let's kind of do our same thing if we were looking at 30 degrees again. We would have a positive answer. Whether we were at a positive 30 degrees or a negative 30 degrees, we still get the same answer, positive square root of 3/2. Because of that even symmetry, it's going to be the same answer for our even functions, but the opposite answers for our odd functions. Okay, so using that property, we can use it to simplify, like we were doing earlier, some identities. So let's do this example. The sine of negative x and times the cotangent of negative x. Well, according to our odd and even identities, what should we do to simplify this? Well, the sine of negative x is the same thing as the negative sine of x, and the cotangent of negative x is the same as the negative cotangent of x. So that changes this positive value to a negative and this positive value to a negative, or if those had originally been negative, because we don't know what x is, then those negatives would of course make them positive. But this is just an identity for any generic case of whatever x value we're plugging in. Okay, but then since we're going negative sine times negative cotangent, what happens when we multiply a negative times a negative together? Well, we get a positive. So we can really just leave those out of the next step. Then we just take this problem from where we were earlier, simplifying problems, and change the cotangent to cosine over sine. Realize that the sines will cross cancel, and our final answer will be cosine. Let's do a little bit harder one. Example number 2. I have 1/1 plus cosine negative x plus 1/1 minus cosine x. Let's simplify this. Okay. First step is to look at the odd and even functions and determine what the odd and even functions tell us about this situation here. since cosine is an even function, the cosine of a negative x value is the same as the cosine of the positive x value. So we can first rewrite our problem with a positive x because of that even function, or the even identity that we just learned about. Okay, now the next step is something we saw earlier, and that is where we want to get a common denominator. To simplify this, we're going to want to be able to add these together. And to add them together, we need a common denominator. So just like if we were going to try and add the numbers 1/3 and 1/4, we would need a common denominator of 12. So our goal would be to turn these numbers into 12s by multiplying this fraction by a 4/4, and because that equals 1. So if we multiply by 1, we're not changing the value of the fraction at all. And then multiplying this one by 3/3, because 3/3 equals 1, so we're not changing the value of that fraction. And therefore we will have 4/12 plus 3/12, and we can just add those top numbers together now and get 7/12, right? Same idea here, 1 plus cosine x is different than 1 minus cosine x. So to get our common denominator, it will have to be 1 plus cosine x times 1 minus cosine x. So this fraction over here will need 1 minus cosine x, and we'll multiply on the top and the bottom so that we're multiplying by 1. This one we would need to multiply by 1 plus cosine x on the top and the bottom, so that we get that common denominator. Okay, so let's do that. Let's write that out. So 1 minus cosine x times 1 is 1 minus cosine x. And that'll be over 1 minus cosine x, 1 plus cosine x. Then we will add that to 1 times 1 plus cosine x over 1 minus cosine x times 1 plus cosine x. Okay, now we just start simplifying. Since we have the same denominator, we can add the numerators together. So 1 plus 1 is 2. But negative cosine x plus a positive cosine x cancels out, and all we're left with on the top is 2. On the bottom, we just have this common denominator that's going to stay the same, but let's go ahead and FOIL out that denominator because these are conjugate pairs. So an interesting thing happens when you multiply conjugate pairs. Stuff cancels out. So go 1 times 1 is 1, and then 1 times cosine and 1 times negative cosine gives us a positive and negative cosine that cancel out. And then we have this negative cosine x times positive cosine x, which is a negative cosine squared. Okay, so now to simplify this further, I want to show you a little thing about the Pythagorean identity. So remember how sine squared x plus cosine squared x equals 1? Since this is already an established identity, it would be fine for us to move things around, like we could subtract the cosine squared from both sides. So therefore sine squared x plus, would equal 1 minus cosine squared x. Anyone see where I'm going with this? Well, I've got a 1 minus cosine squared x right here. So I can actually replace my 1 minus cosine squared x with sine squared x because of that Pythagorean identity. Now, even though there's a 2 on the top of this, that just means it's 2 times 1 over sine squared x, correct? So then we can use the reciprocal identity for cosecant and turn that into a cosecant instead. And there's our final simplified answer. So we went from this ugly thing to this, which is much nicer. There's the whole thing, just in case you need it.